Now let's talk about pointer expressions and pointer arithmetic. Now, pointers can be used as operands, and we just saw that when we used the size of operator on a pointer. But we can't use all operators with pointers. We can use some other arithmetic operators that we haven't tried yet. Some we have tried but didn't think about too much at the time. But certain other arithmetic operators do not make any sense in the context when we are using pointers as operands. So in this section, we're going to look at some of the valid operations we can perform on pointers, some of the operators we can use. And like I said, the set of arithmetic operations we can perform is a bit limited. And here are some of them. There's, for example, incrementation. And if you recall, we already kind of used this. We did it quietly. I didn't talk about it at that point. But when we had this pointer called S pointer, string pointer, in a previous example, we incremented the pointer, the non-constant pointer, to go from one character in a character array to the next. Now at that time, the array, like I said, was a character array. So incrementing, we understand, usually means adding one. So whether we were adding a 1 to the address or adding or whether we were jumping ahead by one data type, that kind of was the same thing because a character takes up 1 byte. But here we'll look at what happens when the array is of different data types: an integer, float, double, anything else. Now, in that example, we only incremented the pointer using the pre-increment operator. We could do the same thing with the decrement operator to go back from the end of a string, for example, from the end of an array to the start. Now, instead of just adding 1 to a pointer, you can add really any integer to it. And just like that, you can also subtract any integer from a pointer. This usually only makes sense when we're talking about a pointer to an array, and only makes sense for as long as the new result that you get from applying that operator is an address that is within the bounds of the array itself. Another thing we can do is we can subtract one pointer from another. That also makes sense, and I'll talk about that too. Now this last one, by the way, this only makes sense when both pointers point to elements of the same array. Let's consider this example over here. We have an integer array called V of size 5. And let's assume that the starting location of this array in memory is at an address numbered 3000. And let's also define an integer pointer called V pointer. So this is a pointer pointing at array V, so that's why we're calling it V pointer. And we initialize it to point to the start, the first element, the 0th element, I should say, of array V. So V pointer is initialized to point at the first element, which is located at address 3000. So basically, V pointer will contain the address 3000 in this case. Now remember that integers are on most systems 4 bytes in size, which means element number 1 of array V will have starting address 3004. Element number 2 will have starting address 3008. And the element number 3 will have address 3012, and the last element V4 will have address 3016. Now, if this pointer V pointer is not a constant pointer, then we can redirect V pointer to point at really any of the other elements in this array. So you can also see that the addresses over here are at a distance of 4 from each other. 3000 to 3004 is a difference of 4. 3004 to 3008, another difference of 4. A difference of 4. A difference of 4. And it's 4 because each integer is, of course, 4 bytes in size. If you call the size of apply the size of operator on this, you'll see that, which we already did. Okay, these values, how big, what the difference is from one element, what the difference in address is from one element to the next, this is of course again all machine dependent. Now, if I had an ordinary integer number, just an ordinary integer number 3000, and if I add 2 to it, the result will be 3002. Now, this is usually not the case with pointer arithmetic. And why is that? That is because when you add an integer or subtract an integer from a pointer instead of an integer, so the difference between adding 2 to an integer versus adding 2 to an integer pointer, what's the difference? The difference is then when you add 2, that is automatically understood to mean adding 2 elements or jumping ahead 2 elements of whatever type is the type of the pointer. So V pointer, for example, if I add 2 to it, the integer 2, this will not make the V pointer equal to 3002. That's not what will happen. Instead, your compiler will check what type of V pointer, V pointer is. In our case, that's an integer pointer. Integers are 4 bytes long on my system. Then adding 2 to V pointer will do this. It'll add 2 times the size of integer. So the answer will be, the new value of V pointer will be 3008. This is very handy, of course. And if you want to look at this graphically, the effect of that statement will be V pointer will now point, instead of pointing to the first element of V, array V, it will now point to, instead of pointing at element number 0, it will now point at element number 2 of array V. Now in a system, just hypothetically, if we had a system in which an integer takes up only 2 bytes of memory, saying V pointer plus 2, adding 2 to V pointer, would make the new value of V pointer equal to 3004. Because on that system, size of integer is 2. So if you want to jump, or if you want to move in an array, if you want to move a pointer to an array, if you want to move that through the array, you don't have to worry, you don't have to remember what the size of the data type is for elements of that array. And as we'll see later, uh, you can even make arrays of structures. And structures can have, well, structures we make completely by ourselves. There's no standard size for what size a structure will have, even on the same system. It's application dependent. So this comes in very handy. Of course, characters are 1 byte long, which means when you do this kind of pointer arithmetic for a character array, like we did a few exercises ago, adding 2 will only add 2 because each character takes up only 1 byte. Now, you have to be a little careful when you're performing pointer arithmetic, because what you don't want to do is end up with a pointer pointing to a location in memory that's not an element of your array. That can get dangerous. Now, just like incrementation, we can also do decrementation or subtraction to perform subtraction to pointers. So for example, let's say we end up moving v pointer to the address location 3016, which is the location of the element number 4 in array v. That's the last one. Let's say we want to come back. Sure, we could do that. We could, for example, run this statement, v pointer minus 4, and that would get us back to address 3000, the start of the array. And of course, like I already said, you can also use the increment and decrement operators on pointers, and we already did something like this a little earlier. You can even use the post increment operator, and this will take you to the next location in an array. Similarly, you can use the pre-decrement or post-decrement operators to move to the previous element of an array. Now you can also subtract pointer variables one from another. So let's say you have 2 pointers. One is, let's say, v2 pointer and another one v pointer, both pointers to the same different places in the same array. Now you may want to subtract one from the other, and you'll get a result. And that result, let's say v pointer has the value 3000, v2 pointer has the value 3008. If you subtract v pointer from v2 pointer, the result will not be 8. The result will be 2, representing the difference in index numbers between this location and this location, representing the number of array elements between these two locations, which is probably what you want anyway. Now, this kind of subtraction of one pointer from another makes only sense as long as the pointers point to locations in the same array. Because if the arrays are two different arrays, if the pointers are to two different arrays, subtracting one from the other makes absolutely no sense. There's no relationship between the address of one array and the pointer of another array. They can really be located anywhere in memory. So while we know that memory for different elements of an array is allocated contiguously, or meaning right next to the other for elements of an array, we cannot assume anything like that for two different variables. So we cannot assume that two variables are stored contiguously. All we know is that elements of the same array are kind of next to each other. Another thing to be careful about is making sure you do not run off the starting or the end of an array when doing pointer arithmetic. Reiterating, make sure you're not subtracting two pointers that do not point to the same array, locations in the same array. Now, you can also assign one pointer's value to another, but there's a condition for that. And that is that those pointers have to be of the same type, meaning both have to be integer pointers or floating point pointers or character pointers and so on. There's one exception to this rule, however, and that is a pointer to void, which we denote as like this, void followed by the pointer operator, asterisk. Now we've already seen void being used primarily as in the argument field for functions and the return type field of functions. Void basically means in this context no or unknown data type. So sometimes you may want to store an address and you do not care or frankly do not know the data type that it is pointing at. In that case, an appropriate pointer type would be a void pointer. So, or you can also think of it as a wildcard, as a pointer that can point to any data type, represent any pointer type. And what you can do, what this basically allows you to do is you can assign all pointer types to a pointer of type void. And similarly, you can assign a void pointer to a pointer of any other type. In either case, you do not need the cast operation, but you do have to remember that a pointer to void cannot be dereferenced. And the reason for that is void is not a real data type itself. For example, an integer pointer. We know an integer on a machine is, let's say, 4 bytes in size. Void has no size like that. So you do not know where the data at that location starts or ends. It is an unknown data type. In order to do anything like that, a compiler must know the data type that a pointer is pointing to. Now, another thing that we may have to do is compare pointers to check if two pointers are pointing at the same data to the same location. And we do that, we compare using the comparison operator, of course, two equal signs. Pointer comparisons, compare addresses. And what you can do is doing other comparisons like greater than, less than. What you can do is you can check if which of two pointers is pointing to an element in an array that comes later than, which one comes later, which one points to a later element in the array, which one points to an earlier element in the array. So you can do that too using the greater than, less than symbols, those comparison operators. Another comparison that is often performed is a comparison with null. This is basically used to determine whether a pointer is actually pointing at some location or not, or if it's pointing at nothing, if it has been initialized. So assigning a pointer of one type to a pointer of another type is an error, unless one of them is a void pointer. Remember, however, that it's not possible to dereference a void pointer. And finally, it makes little sense to compare two pointers that do not point to the same array.